Hello everyone. Today, many companies are generating different LLMs to be used by thousands of users around the world. The main concern of these companies is the authentication. In other words, no one should be able to lie about using a specific LLM to generate a specific content, such as an illegal content. So the main challenge is authentication. There are some solutions out there, but they have some limitations, especially the ones that are based on ZKPs require to have access to the internal parameters of these LLMs, which is a privacy challenge. So what is our solution? Our solution is based on blockchain. The vendors are registered in a smart contract by the owner of the smart contract, and the public keys are also registered. When the vendor wants to generate a signature for his proof, he calls a function in this smart contract, and the contract generates an event. The trusted node sees the event and generates a signature with his own secret key and the inputs, which are timestamp and model ID, for example. Then this signature is encrypted with the public key of the vendor. And this encrypted signature is sent to the vendor and also the zero knowledge layer. The vendor can decrypt this signature with his own secret key, and then this decrypted signature will be sent to the zero knowledge layer. So the zero knowledge layer has two inputs: the decrypted version of the signature from vendor and the encrypted one from smart contract. Zero knowledge verification layer can then decrypt the one received from smart contract using the secret key of the vendor, and then he can check whether those two are matched or not. If so, then a proof will be generated, and that can be also verified on chain. So the advantages are we don't embed the watermark inside the text. In other words, we do not reduce the text quality. We do not use the patterns inside the text generated by the LLM. Those patterns can be learned by malicious actors and used to game the system. So our system cannot be gamed. And it's really, really cheap in terms of computation. So we have a smart contract which adds transparency, a real-time signature generation which adds security, a ZKP circuit which adds trust, and the proof can be also verified on-chain. So then these are the results of our simulation. The proof generation time of almost 3 seconds and the proof size of almost 800 bytes shows the efficiency. Thanks.